Today we are starting a new series on NeetCode 150. NeetCode 150 is a curated subset of LeetCode problems. There are thousands of LeetCode problems and in a short time you cannot solve all 3 or 4,000 of them. NeetCode has curated 150 problems that cover all the key topics and will prepare you quickly for your DSA rounds or coding interviews. Today we will tackle our first challenge. Our first challenge is the two-sum problem, which is in the easy category of NeetCode 150, and we will solve it in Java. This is the classic two-sum problem that we are going to solve. Let's first state the problem. Given an array of integers, nums and an integer target, return the indices I and j such that nums I plus nums j equals target, where I is not equal to j. You may assume that every input has exactly one pair of indices I and j that satisfied the condition, and you should return the answer with the smaller index first. Let's solve it in Java. We will walk through two examples. Here is the first example. So what are we trying to find? We have an integer array of 4 elements 2, 7, 11, 5, and we are given a target of 9. The target means that if we add any two of the array elements, one pair will give us 9 as the sum. Here we can see that 2 plus 7 sums to 9. So we don't need to go any further, and we can set the output as 2 plus 7 equals 9, and the output will be index 0 and index 1. Now example 2. Here we are given only 3 elements, 3 integers with 3 indices. Index 0 plus index 1 is 3 plus 2, which is 5, not our target of 6. But in the case of index 1 plus index 2, which is actually 2 plus 4, that satisfies the target of 6. So we can say 2 plus 4 equals 6, and the output will be index 1 and index 2. So first let's look at the solution in pseudocode, not yet in Java. We have taken a list of numbers 6, 9, 3, 11, 23, 27 and 18, and we are going to traverse them one by one to see which pair makes the target 25. We will start at index 0, which is 6, and we have created a hash map. The hash map stores which elements we have already traversed, and I will show you visually how the logic continues. So first we have 6, which is at index 0. To reach the target of 25, what number do we need to add to 6? That is 19. So our complement is 19, which is target minus nums I. In this case, 25 minus nums 0, which is 6, is 19 in the map? No, because it's empty. So what do? We are going to put the current number, in this case index 0, into the map along with its index. That means the map now shows that we have already traversed index 0, which has the value 6. Now let's move to the next number, which is 9. The target is still 25 and the complement is 16. Is 16 in the map? No. So we will store 9 at the index 1 for later. The same way we will do this for 3 at index 2, 11 at index 3 and 23 at index 4. So far no match yet. We still have not found any pair that makes the target, which is 25. Now let's move to the next one. Here we are currently looking at 2 and the complement is 23. Is 23 in the map? Yes, it is in the map. So the value we are currently on and its complement are both in the map, and together they make the target of 25. 2 plus 23 equals 25. So we can say our search is complete. We are currently at index 5 and index 4 complements the pair, summing to our target 25. So we return index 4 and index 5 as the result. The method returns immediately because we have already found a match and the complement is present. So the final output will not show no pair found because we have already confirmed we found one. So that was the pseudocode. Now let's implement it in Java. The algorithm is the same. I will show you how the Java code is written. You can see it checks for the complement, adds it to the map, then moves to the next number and checks again whether we have found the complement. no match yet, and continues. It keeps going the same way and eventually it reaches 23 and then 2 and finds the matching pair. Now let's calculate the time complexity and space complexity. We will focus on time complexity first. There are three cases: best, worst and average. Let's start with the best case. You can see we have our numbers and our target is 25. In the best case, you find the pair within 2 iterations. Here 12 plus 13. We found it in 2 of 4 steps and we return index 0. You can see the number of steps scales with the iteration count. So we can say this is O order of n complexity. Now the average case. In average case, we can find the pair anywhere between the first and last elements. Here our target is 31. Let's see. 4 not found, 8 not found, 15 not found. In step 6 we found 15 plus 16. So it was not found in the first 2 steps. But by step 6 we found it in 4 steps. So this is also order of n, and space also increases with the number of elements. So space complexity is order of n. Now our worst case. Our target is 14 and the worst case means we have to iterate through all the elements to find the required value. 1, 2, 3 not found, 4 not found, 5 not found, 9 found. So there are 6 steps and we found it in step 6. This is also order of